You know what? I'm just going to go ahead and start the stream slightly early because I have stuff to talk about. Oh my god. Okay, hold on one sec. Let me turn the music back on part of the way. So, you might be wondering why instead of Clip Studio Paint up, I have a scientific study up, and that is because I have been waiting for the results of this study for like years. And and I was just alerted that that the study was finally published, like right before the stream. Is this what I think it is? Yes, it is. It is the lunar gravity mice experiment. I can't believe the day has finally come. Holy crap. Okay, if you don't know why we're so excited about this, it's because up until now we have had zero empirical data on what long-term exposure to gravity conditions that are less than Earth's, but not zero, actually do to vertebrate physiology in the long term. Which means for implications, like, we don't know we didn't have like any idea what kind of health problems someone living on a moon base long term or a Mars base long term would suffer. And this is finally actual empirical data on the subject. Holy crap. I haven't had time to fully read through this, and I'm going to save until after stream to fully read through it, mainly because I don't want to just read out the whole thing. But from what I've seen from the abstract and elsewhere, what it seems to indicate is that there is no muscle or bone atrophy in lunar gravity, which is incredibly good news. It means you can pretty much, it would basically mean you can stay in lunar gravity indefinitely without serious health problems, but it induces transition of muscles from slow twitch to fast twitch. If you don't know enough about anatomy to know what the difference is, there are two main types of muscle: fast twitch and slow twitch. Fast twitch muscles are precise and respond very quickly. Slow twitch muscles have way more resilience to fatigue and raw strength, but get tired, but don't respond as quickly. So this is basically saying that your body starts optimizing its muscles because it doesn't need lunar gravity trances you, because you don't need as much like raw strength or fatigue resilience to like lift your body or walk around in lunar gravity, right? So what happens is that your body instead it starts turning those muscles into fast twitch muscles, which respond quicker and more precisely, but aren't nearly as resilient to fatigue, which is really interesting, and it's not necessarily bad if you're staying in space, but it does mean that if you spend a lot of time in lunar gravity without doing stuff to counteract this, when you come back to Earth, you won't be able to stand up. because like standing up and walking depends on slow twitch muscles. What's funny about this is we also kind of like understand the biochemical underpinnings of this effect. So it's possible we won't even need specific exercises to counteract it, which, like, I can already say what kind of exercises would do. Endurance training exercises, the entire point is to induce the transition to slow twitch muscles, so it would effectively counteract this. Can you jump out of your seat with fast twitch? Yes. That's the kind of thing fast twitch muscles are for. But stuff like holding a weight, just like holding a weight up for lengthy periods of time, like when you're just standing, is something slow twitch muscles take care of, or for. Bunny hop. No, the problem is just that you'd find standing up under Earth gravity, if your muscles had transitioned like this, to like be just exhausting just to stand up. Pretty good. I'm doing wonderfully because this study finally came out. Holy crap. I linked it in my Discord, too. Like, I'm going crazy that this data is finally available. Hold on one sec. I forgot to change the priority of VTube Studio. Can we have more gushing over interesting papers? I might turn that into an actual thing, yes, at some point. But yeah, this is like breaking my mind. I came here to do an art stream though. I'm supposed to be doing an art stream today, and that's what I'm gonna do. But I just had to talk about this because this is driving me crazy that we finally have this data. Like, holy crap. Okay, okay. So it's super pixelated. It just turned off the music again. Hold on. I don't know why it would be super pixelated. It's probably an internet issue. I don't think it's my internet, because it doesn't say it's having problems. It's probably your internet, Sylvie. Okay. So let's like talk about what we're doing today, because like I said mechanical drawing and I want to design stuff, but like we are doing actual hard sci-fi, actual like detailed designs. And so we want to talk about like the actual mechanics of the design first. So we're designing a laser weapon that I've had an idea for a while for my own personal setting. I've already worked out pretty much all of the math that needs to be worked out and can freely discuss that, and we'll be discussing that prior to this instead of like spending several hours doing math like it took me to work out all the information. But basically this is an infantry laser weapon meant to perform the role of like a primary service weapon for infantrymen. In the context of my setting. But first, in order to talk about what a weapon does and what role it performs, we really need to consider what you're shooting at and what kind of defenses it has. I've mentioned in various places that my setting has this like fancy meta diamond armor. That has like some pretty redonkulous mechanical properties. I'm gonna explain these in detail, and I'm just gonna like draw to explain it. So I call this like armor concept nacreous diamond. I call it nacreous diamond, which isn't a very catchy name, but it very accurately describes what it is. It's a concept that a physicist friend named Luke Campbell offhandedly came up with, and which I worked out the details on. Because I thought it was a really interesting concept, and it turned out to work way better than either of us actually expected it to. So, if you don't know how Nacre... Well, I only know him through Tough SF, but we talk a lot, so... like, a physicist acquaintance, I'll say. Yeah. So basically the idea of nacreous diamond is, so the shells of certain mollusks are made out of a substance called nacre, which what that is it's a bunch of tiny tablets of aragonite, like, let's just lazily draw some little tablets of irregular shape and width, but regular thickness, layered on top of each other such that they don't actually line up, sort of like this, suspended in a matrix of chitin fibers. So that's like switch colors just to represent the chitin. So you have like chitin fibers running all through here, and 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 through here. Basically, this is because aragonite, while reasonably hard for like a biomineral, it's fairly brittle and fractures easily. By doing this, the polymer matrix can flex a little, and which will allow it to resist transient loads without like fracturing, just because like it collided with something mildly hard, it won't cause cracks to form. And also, when it does get hit by something hard enough to fracture it, it will arrest the fractures. So instead of like it splitting all the way through, you'll get like individual tablets will split. Which creates a much more resilient thing. And the armor concept of nacreous diamond is we do this except with similarly scaled platelets of heterodiamond, which is it's diamond except the structure is boron, carbon, and nitrogen instead of just carbon. And instead of chitin for the polymer matrix, we use a high performance polymer. Like I suggested using something like some futuristic ultra high molecular weight aramid. How would you make this kind of diamond anyway? Laser synthesis, probably. And anyways, when I get to the point, this has a bulk compressive strength of around 60 gigapascals. That is about 20 times that of steel. And it's also much lighter than steel. The math we did on, like, let's see what a tungsten long rod penetrator going 1.8 kilometers per second does against this versus rolled homogeneous armor, because we expected, because of the lower density, it wouldn't actually perform all that well. So like a tungsten long rod penetrator akin to that fired by an Abrams tank cannon, it just completely fails to penetrate. It's like the tungsten long rod fired by an Abrams tank just splashes against the surface. So needless to say, what about like pressure and shock? So there's more complicated damage mechanisms that would be a worry here. Depleted uranium is even worse. Depleted uranium is even worse because it's softer. So needless to say, this renders traditional chemical firearms completely irrelevant if you have armor made out of this stuff, because like they just splash. It doesn't matter. Like, you physically can't make a chemical firearm that can penetrate this without making it just so ludicrously large that it crushes it. Useless for penning, that is. Yeah. 40 mm heat. Yeah, heat works. Heat works because the tip jet velocity is actually fast enough. We did the math, and it turns out coil guns have the problem that if you're shooting one with enough muzzle energy to penetrate this, then you're going to knock over the person. Then the person shooting it will be like knocked off their feet by the recoil. Yeah, you'd still potentially get your ribs cracked if you don't have like shock absorbers and stuff, but like it just doesn't penetrate. And so what I eventually settled on was a laser weapon, and specifically a laser weapon optimized to defeat this armor, because this is like just a common infantry armor, typically in the form of like different thickness plates all over the body, arranged like somewhat similarly to European articulated plate armor from the late Middle Ages or Renaissance. And these plates vary from like 1 cm thick to 3 cm thick. So what we do is we sort of exploit the fact that this polymer matrix has a much lower melting point and boiling point, and thus much less energy required to vaporize it. Still pretty freaking bulky despite the weight. Yeah, they have like low grade power armor that they use with this. That's mainly just designed to reduce the weight of the armor. The like effective weight of the armor felt by the wearer. So it doesn't really like feel like you're being weighed down when you're wearing it. And so basically what we do is we use a laser with 2 alternating pulses. We use a relatively long pulse with a wide spot size that just heats up the material and causes the polymer matrix to melt and start to vaporize. And we follow that up with a much shorter pulse with a much narrower beam that instead just straight up like vaporizes at extremely high energy a very small volume of the material, which forces the platelets that are no longer suspended in the polymer matrix out of the hole, creating a hole in the armor. And we just do a train of those pulses in sequence to penetrate. As you can also see, I don't have a very steady hand because I haven't practiced in a very long time. I used to have a very steady hand, but I don't anymore. I can still kind of do that though, like a very straight line. Are you drawing with a mouse? No, I'm drawing with a tablet. There we go. That's a very straight line. And 2 grams of CC, that's 30 kilograms. Yeah, which isn't that much. Can I do a circle still? No. Well, I was always bad at circles. I couldn't do circles on the first try even when I was good. But yeah, I need to get back into practice before I have a straight hand, before I have like a straight hand again. You should install Blender. I was gonna try and learn Blender at some point. At some point, I'm definitely gonna try and learn Blender. Yeah, I admit, like, I kind of suck right now because I haven't really seriously tried to do art in like over a year at this point. So I'm like about as out of practice as it's possible to get. So I'll just like start writing out. So we have my fancy laser damage calculator math here. You can see how whack it is and why this took me many, many hours. But let's go ahead and just like write down some stats. So first of all, we use, I may have to borrow some of the details. Yeah. So we use about 305 nanometer light. This is like mid UV. Post Desmos link, please. Yeah, I'll post it actually. Yeah, I'll share that. Laser damage calculator. Dirty desktop, dirty desktop. Yeah, I haven't cleaned up my desktop in a long time. So we use 305 nanometer light. This is like the mid UV range. It's very slightly a small enough wavelength that your corneas are not transparent to this wavelength of light. Why is that important? Because a weapons intensity laser that is a wavelength of light that actually can go through your corneas, if you look in the general direction of that laser, you will go instantly and permanently blind. It will completely fry your retinas in a fraction of a second. So this is just barely high enough frequency that that doesn't happen. Well, you can just wear goggles. You can just wear goggles. But if you're not wearing goggles... But yes, because of that, it's designed to use a wavelength of light that doesn't actually just instantly and permanently blind people nearby. This wavelength of light is also invisible, but the laser is not completely invisible because of two reasons. The first is that it will use longer wavelength seed beams to preempt Raman scattering. That is a whole lot of complicated physics I'm talking about, but basically Raman scattering is a complicated concept where like your laser induces stimulated emission in the air in front of it, which basically just makes you lose energy from the laser. It just becomes light. So in random directions. So we preempt that by doing the lower wavelength that Raman scattering happens at in the same direction as our laser. So when Raman scattering happens, the Raman scattered light goes in the same direction as our laser. Oh, I already described how the pulse works. Yeah. So, and those lower wavelength seed beams for countering Raman scattering are in fact visible. They're blue. So you'll see like a twinkling blue light. It's not that intense because it's just to preempt Raman scattering. It's not part of the actual weapon. So, and also we get some 2-photon ionization going along the path of the beam over a kilometer distance, which is the maximum effective range. It loses about 10% of its energy. to 2 photon absorption along the path of the beam, which will cause like some ionization of the air. So even aside from that little like low intensity blue beam, the air will slightly glow along the path of the beam. The other thing is we want a somewhere in the range of 5 to 8 centimeter aperture. Why is this? So, lasers are whack. It's like, if you don't know how lasers actually work in real life, people tend to think of lasers as being like a narrow beam of light that just goes in a direction like this. But in reality, it's more like how you, like, you know how kids will like use a magnifying glass to focus light onto ants and fry them? That's more what a laser does. It's like this. And so you have, and because of that, you run into a problem with diffraction, which is the tendency of light to bend around corners. Which is, it becomes a problem here because it bends around on the sides of the aperture the laser comes out of. This effectively determines your minimum spot size at a given distance, which in turn affects what is the effective maximum range of your laser under ideal conditions when there's no beam attenuation going on. And so in other words, we actually need an aperture around this size to get the kind of effective range we want from the laser. Because making the aperture bigger makes it so you can have a smaller spot size because it lessens the effective diffraction. The other way to lessen the effective diffraction is to use a shorter wavelength. We are already using a very short wavelength. You can't get much shorter than this. Bigger lens equals smaller direction. Gamma lasers. So a gamma laser would not work in atmosphere. It would just get absorbed by the air. Nanomeme wrapped tungsten projectiles fair. So the actual better option to do there is to use tungsten carbide, which we worked out, but you still need like 4 kilometers a second velocity to penetrate. CKEM style thing. The problem is you can't really miniaturize that to be good for an infantry weapon. Like tanks in the setting use coil guns, but as their main armament, but infantrymen use lasers because a coil gun powerful enough for this would literally knock you off your feet firing it. We have like a total pulse train energy of about like 30 kilojoules. If it's so overbuilt for more projectiles, that'd mean you just use less of it. Yeah, but it doesn't like cost very much to make in the context of the setting, and the power armor can easily counteract it. So like this is enough to make most chemical firearms useless. So like, yeah, they don't use more of it than they need, but yeah. Do gun people get really pedantic if you call an infantry laser weapon a laser rifle? People do, yes. We have we have a total pulse train. How fast does heat need to be going for it to work? So just like a normal average heat jet has a penetrator tip velocity of like 8 kilometers per second. So it easily goes fast enough. A 40 grenade launcher, but heat. Yeah, that would work, but then your bullets are huge. So anyways, 30 kilojoules. It may not be obvious, but this is actually like a ton of energy. This is around 10 times the muzzle energy of a 7.62 NATO cartridge that is used by the M16. It's several times, it's like more than that used by an anti-material rifle. If you shoot this at an unprotected person, they will be straight up gibbed by it. Like, they will be reduced to spattered gore. What else was stuff I need to get out? Okay, oh yeah. We then use a power cell. I'm trying to outline what the requirements we want are. Literally vaporized, not blown apart. No, they'll be blown apart. They'll be blown apart. Will they die if the bullet whizzes next to them? No. That's something particle weapons do, not laser weapons. Thank you for the head pats, Terrakia. I switched to text. Oh, yeah, you finished it. Oh, yeah, you finished Signalis, didn't you, Terrakia? Okay, so, you've got a dumb question. What is it, James? How would this armor react to a backblast from a rocket launcher such as the Law or RPG-7? I don't know. I don't actually know. Handguns seem to have around 0.5 kj muzzle energy, so it's like a lot, but not totally insane. Yeah. Yeah, it's significantly more than an anti-material rifle's muzzle energy. You will explode into chunky salsa if you get shot with it unprotected, but it's not like going to knock down a building. Actually, real quick, I'm going to take a bio break. All right, I'm back. Okay, so Next topic to talk about. Lasers generate a lot of heat. Even the most efficient lasers are only about 50% efficient, and the rest of the energy you put into them just becomes heat. So we need a way to bleed off heat. And my plan was along the like front end of the weapon, we'd have like a shroud that inside of the shroud we have heat pipes running back to the laser generator. And those would exchange heat with the atmosphere. I did the math on this, and it turns out that in an atmosphere via convection cooling, this is easily good enough if you can run it pretty hot, and the laser generator tech we're using can run pretty hot. What form of coolant in the pipes? We literally just use water. It's fine. I mean, technically, using water slightly increases the likelihood that the weapon explodes if there's a short, but who cares? Anyway, so like, yeah, we need a heat exchanger. But also, because this weapon is designed to be used out of atmosphere too, we want a line that connects where you would normally put a power cell that serves as a connection for both coolant and power from an external source potentially. So like in an EVA suit loadout, you'd have like your backpack generator and heat exchanger, and you'd hook that up to the weapon. Mineral oil may be preferable. Yeah, it's not quite as good, but yeah. Like putting a water jacket like on World War I Maxim guns. So anyways, we need radiator. We need it to be fairly long. And a coolant port for exoatmospheric use. And we need a coolant port for exoatmospheric use. What are other things? Oh yeah, it has a single lens reflex sight. That might be a little bit confusing, but what I mean by that is like laser optics are just camera optics in reverse. So you can just use your laser optics as camera optics. Is laser turreted or is it fixed? It's fixed because it's a infantry weapon. You point it at something and it shoots. Yeah. Wait, infantry? Yes. Vivi, what are you trying to do? Blow up tanks with special forces? 30 kg is not that much. Tarakia, you missed the armor explanation, yeah. Why is it holding that for bullying? Anyways, sorry, I'm trying to think for a second. I lost track of what I was thinking about. Oh yeah, I was talking about the sight. So when I say a single lens reflex sight, like laser optics are just camera optics in reverse. So we can just use the laser optics as our sight optics. like, we don't actually need a separate sight that goes on top of the gun. We have a port for a sight that just sees through the part of the gun the laser comes out of. Well, yeah, the frontal armor of tanks in this setting is like 1/2 meter of this stuff, so... along with other stuff, too. So, yeah, and because we need to focus it at a specific distance, what actually happens when you pull the trigger will be it sends out a very low intensity laser pulse, which it then reads coming back the same way a laser rangefinder does to find out how far away the thing you're pointing it at is, and then uses that information to tune the optics and then fires the laser. This sounds like it would be a lag, but this entire process happens over the course of millionths of a second because laser optics can change very, very quickly, change their focus very, very quickly. So you don't actually notice the delay. And yes, it uses superconducting magnetic energy storage as its power source. I experimented with doing wacky things with fuel cells, but the primary issue with that is that adds to the heat burden a whole lot. Simply use a nuclear battery. Not this small. And so, if I find it, I can find Luke Campbell's. I'll just bring up Luke Campbell's laser weapon designs to show what I mean with the sight being sort of integral and not having a port. Like if you see, like you look through there and you see out of there, which is the same place the laser comes out of on Luke Campbell's designs. Well, it's not really aiming itself. It's more like self-tuning for target distance. So you don't have to dial in the distance of the target. And as you can see, the end of lasers looks sort of like a camera. That's just a general property of lasers. We use a fancy futuristic diamond lens that has like really hilarious intensity tolerances. Yeah, Luke's laser guns are great. I'm designing for a slightly different set of assumptions though, so I need a slightly different design. Oh no, I set the gun to live stream. Where's Eraser? Because we are now going to get rid of all this shit because we don't need it anymore and actually start drawing. Well, I mean, this is an infantry laser. You have to be operating at ranges where the infantry can actually see each other. Means robots with I-beams makes total sense. Yeah, you can easily just use laser optics. If something's designed to be laser optics, you can very easily use it as a camera too. This is also part of why weapons intensity lasers fry your eyes, because the lens in your eyes will refocus the light onto your cornea at high intensity, onto your retina at high intensity, and fry your retina. Which is why it's important that we choose a wavelength that the cornea is not transparent to. a space combat laser would also have that problem, or what do you mean by that, Psi Operator? Can make my power armor's camera systems using just a small dazzler. It's more like you engineer the dazzler, and then you can also use the dazzler as a camera. What if we were trying to kill a puny human? Would aiming at the eyeball be optimal? But can it camera and laser at the same time to focus light into their brain? I mean, at these intensities, it's not going to focus light. It's going to... Their eyeballs are going to disintegrate before they actually focus light at weapons intensities. It's just they'll focus them enough to fry your retina, even when you're not actually getting that much of the laser's light in your direction. Can it camera and laser at the same time? I don't believe so, but it can switch modes basically instantly, so... I wanted to, like, sort of base the dimensions off the XM25. Because it's a really, really bulky gun that fits for the size of aperture we need, while also being, like, reasonably ergonomic. Hold on. In theory, you could have it take a picture of the winning shot. Oh, oops. So we want to kind of copy this over. Oh, I selected it wrong. To use as sort of like a base for the ergonomics. And we also want to get it to scale. I would like to do like 1/10 the scale on this piece of virtual paper, at least partially because it doesn't actually let you set the scale manually. That's like almost correct. That was not straight. And then how big is the XM25 again? I know it's somewhere in the range of like 70 centimeters. 749 millimeters. Okay. I totally forget how to rescale stuff in... Ah, that's how. Yeah. That's very slightly too large for the scale to be right. There, that is the correct scaling. And we can just move that to the center. Ah, crap. I canceled the transformation. I'm very dumb. You can tell it's been a while. Okay, that is correct scaling. And we'll just move that to the center of the page. I totally forget how to control this. And then we need a new layer, a vector layer, where we're gonna actually draw our like guidelines for the shape of this. I'm planning on actually doing this as like a high resolution pixel art. So here I'll just be drawing like the vague shape of it. I also want to like sort of use, so one fun idea I had was, you know how I mentioned the integral single lens reflex sight? I was thinking of using the like general shape of the Halo assault rifle's digital display as its scope, because it would just, you just like see into there and it takes information from the end of the weapon. The rifle up, I can make that optics panoramic. I was holding my pen wrong. So something like, if I can manage it correctly. That is actually way too wide. I like this. I also should use straight line for these guidelines. I hate how thick that makes it. Instead, we will just use a ruler and then draw along the ruler. Is there a way to get rid of rulers? That's straight enough. It's also straight enough for a vague guideline for like the main body of the gun. We don't actually have any need for the gun to be bullpup. We're going to put the power cell and connections here. We're going to put the power cell here, but we're going to put the connection port back here so that the cord doesn't get in the way when you're holding it, when it's connected to an external power supply. But we'll go ahead and just like sort of copy the shape of the trigger and trigger guard. I want to, unlike this, have the bottom of the trigger go sort of like that. And connect up. And then we can have some volume of space that is open like that. And you can sort of see the gun start to take start to take shape from this. Spike light from Israel. Oh my god. Anyways, we have like sort of a block like that for the ammo. And to assist in holding it, we will have like a little ergonomic grip coming down here. And across like this. And like this. Magwell grip Yabe. It's the Clone Wars Slot Rocket Launcher. This is super. Yeah, it's Smez. And we also, of course, want to extend the stock further. Something vaguely like this. They're like Tauruses. Can we just integrate them like into the main body? We could integrate the ammo some other... We could integrate the power cell some other way. Actually, that makes me recall that the power cell, if it's a superconducting magnetic energy storage cell, should probably be like a flat cylinder disc. Anyways, this is sort of our lens here. Well, we probably want it to have a more square shape, just so, like, it's easier to handle, even if the actual smez inside is circular. Would the smez act as a magazine? Yes. Hexagon. Yeah, whatever. We'll leave, like, the internal geometry vague. We'll just use a square box. Combined power pack and heatsink that fits around the barrel like a Maxim water jacket. Well, I was going to have a shroud that is just for, like, convection heat exchange with the environment.
I came to laugh at you.
Oh, hey Max, thank you for the raid. Conveniently bullet-shaped SMEs for the thing with enough shoes for a single shot. the RF that's being traced. I'm sort of tracing, but only sort of. I don't think we actually need the XM25 as a guide for proportion anymore to be shown. The InDesign goal is, this is for my setting, yeah. We'll probably do something fancy, like have like little struts over this when we do the higher resolution pixel art version, the fancier pixel art version. But again, we're just doing sketches for shape right now. That part has been going well? Yeah. Although I spent like the first half of the stream so far, actually more than half, explaining all the design elements that are going into this. Let's change the base of the stock. I think while we have this being circular, I'd like rather it kind of be just for the sake of ease on me and for the pixel art, actually do it as like a square thing instead. Where like the lens itself is circular, but the body of the weapon is like squarish. Laser weapons don't have recoil. Or at least they have negligible recoil. We also don't need the whole gun to be that wide. God damn it. God damn it, draw straight. There we go. We also don't need the whole gun to be so wide and square. Let's extend the wide end section of the gun as far back as like the scope goes on the XM25. Yeah, mounted on a piddly little rifle base. That's sort of what I was going for. And then we can have it sort of just... like this part extends out in 3D. Oh, all the emotes are finally approved. Thank God. They were finally starting to approve more of them last week, but now they're all finally approved. Yay. Yeah, I'm going to look at the P90 again.
Don't shoot! I'm with the science team!
Oh, thank you for the subscription. I forgot how fucking loud that sound was. I need to fix that. Yeah, that made me jump in my seat. Holy shit, I'm fixing that right the fuck now.